Hello, audiences. Welcome in everyone to, well, what do you know? It's another one of these lovely Into Games discipline deep dives on a lovely Wednesday afternoon. Thanks for joining us. Hi, I'm Jonas from Into Games, and yeah, today's discipline deep dive. If you don't know about these talks, I'll sort of mention a bit, but today we're going to be doing a talk that's a little bit more focused on the programming discipline, specifically talking about sort of like game engine concepts and how that intersects with programming and language and all that technical codey stuff, print hello world and all that. See, I know what coding is. If you haven't already seen one of these discipline deep dives, or this is your first time sort of seeing anything from Into Games, Into Games is an organisation that really tries to help the games industry, specifically in the UK games industry, just be more accessible. And a few of the ways that we do that is just by trying to make sure that like resources and talks like these can be sort of widely available for free, as well as going out and doing some outreach around the UK to try and help bridge the gap between like education and industry, and also just supporting areas of low income and things like that. This talk in particular, or these discipline deep dives in particular, they're sort of, we designed them around a resource that we call the Entry Level Games Hub. So if you haven't heard about the Entry Level Games Hub, like, please do go check it out. There's a little linky thing running away down there. That is a resource that basically looks at some entry level jobs in the games industry, some really common ones, and says like, what are the common expectations of the roles, what are some portfolios that have succeeded in getting people those sorts of roles, and what are some resources or tools that you might need at your disposal to sort of make yourself more prepared for those roles. And what we've done is we've looked at each one of those roles now, and we've started turning bits of knowledge and skills and things like that into individual events. So this in particular event is like, we looked at what junior programmers are expected to know in the industry, and we said, well, they're expected to know a lot about like game engines and concepts that are talked about in games and game engines, and they're expected to kind of, be able to talk about those a little bit proficiently. So we thought we'd make events that taught you, the audience, how to do that, so that you can go ahead and do that when it comes to sort of trying to get those entry level roles. Now, of course, I'm not going to tell you anything about programming and coding and games engines, because I've never heard of a Unity before. But thankfully, Paul Robertson has. Paul Robertson, welcome to the stage. How are you doing?
Hi, Jonas. I'm doing really well. How are you?
God, then I never get asked back. I'm great, thanks. All the better for hosting a great event like this with yourself. So Paul, tell us just a little bit about yourself. Who are you? What have you heard of Print Hello World? Maybe a bit more than that.
I've done a few Print Hello Worlds. Yes, so hi, I'm Paul Robertson. I'm a senior programmer at Ninja Kiwi. Prior to my time at Ninja Kiwi, I was a lecturer in games programming for more years than I care to admit. Um, yeah,
Nice, brilliant stuff. Thank you so much for joining us. I'm just seeing everyone in the chat, by the way. Hello, everyone in chat. I hope you're all doing well out there, and yeah, I hope you enjoy the talk that you're about to witness. So, Paul, you've brought some slides, which I'm about to bring up onto the stage now. There you go. Paul, I'm just going to leave it to you now to get chatting about all the things that you know and sharing your knowledge. Everyone, please do give like a warm applause to Paul in chat. Your little clap emojis, or just give a little wave. And at the end of the talk, we'll do like a little bit of a debrief, maybe a bit of a Q&A as well. So please do stick around, and if you've got any questions throughout the event, feel free to just put them in the comments, and we'll do our best to come back to them later. Right, Paul, they're all yours.
thank you very much. Right, so before we get started, I would say this was put together a little bit short notice, so I apologise for any rough edges. So one of the things we're going to do is we're going to have a quick look through some existing engines, some of the more common ones you might have heard of or had a chance to play with. Talk a little bit about engine architecture, along with some of the programming methodology, so how some of the elements are hooked up. I can't talk about everything, would be here all day. Dive in a little bit into visual scripting. This is something we interact with quite a bit, and is really handy, but you sort of approach it from a different perspective as a programmer. Talk a little bit, a quick example. This is based off one of our older games, so I can't say a huge amount, but we can talk a little bit about that, and then finish off with some advice for people studying at university, people looking at getting their first junior job, some things I'd recommend around that, and then hopefully we'll have some time for questions at the end. So looking at a couple of engines, so obviously we've got something, Unity, I'm sure everyone's heard of this. One of the big advantages is it makes a nice wide selection of games. So what we've got here is we've got first-person shooters like GTFO, we've got VR games like Beat Saber, and some really fun 2D games like Hollow Knight. So the advantage of Unity is that wide breadth of games that you can make with that, and that compares to other engines we might look at that are a bit more focused. Unity, the way we spend a lot of time interacting with it from programming point of view is either with C#, C++, or visual scripting. The C++ stuff is a little more complicated. We end up having to strip out bits of the engine, so building our own C++ libraries, which we can then interact from within Unity. Unity also has strong 2D and 3D capabilities, making a wide range of games. It has some big advantages like the asset store, all of its plugins, and a large indie community as well as sort of AA as well. Onto Unreal. Obviously, slightly, as you can see, is a big change in the type of games made with the engine. So obviously what we have is Sea of Thieves, big, massive open world games, similar things, Borderlands and Hellblade. One of the interesting things with Sea of Thieves, I happen to know too many company secrets, so they actually work with both Unity and Unreal. They run a grey box version of the game in Unity as a prototyping phase. So they do a lot of their quick prototyping in Unity for new features to test things out, do play tests in the office. If they're successful, they then rebuild them properly in Unreal into the main game. So really interesting way to see people using more than one engine. Obviously, Epic have Fortnite in the bottom right. Obviously, they've spent a lot of time building this game to really showcase what the engine's capable of. This is actually a really strong advertisement for them, where you can see what can be built with the engine. Unreal, they've been pushing the boundaries a lot, especially with Unreal 5. So you're now looking at them as an industry leader in 3D rendering. So if you want to do really high-end visuals, good choice in engine. So you're looking at things like global illumination, their new nanite system for high resolution assets, a complete rework of their chaos physics engine, so you can make things hugely destructible, lots of fun. Their MetaHuman creator, which is a lot of fun to play around with, where you basically video capture live action and map that to in-game animations. Mainly focusing on facial animations, but this gives you a really strong starting point for any animations that you need to put into your game. Sadly, not everyone has a mocap studio in their basement. When you think about engines, Unreal, you interact with it from a programming point of view, primarily through C++ or blueprints. From a programmer in the industry point of view, we spend a lot more time in the C++ side. We'll do some blueprinting. We'll get a bit more into why when we talk about the visual scripting in a bit. And one of the really interesting things we're seeing with Unreal is its growth in use outside of the games industry. So what we're seeing is it being used a lot in virtual production, in film and TV. So things like the Star Wars show Mandalorian, a huge amount of what you're seeing in that show was actually just Unreal rendering in the background and actors and acting in front of a really large screen with some virtual production, and it's hugely impressive to see what's being done there. Cool. I want to mention GameMaker. So GameMaker is a 2D focused game engine. Some examples of games that they make with it, Hyper Light Drifter and Hotline Miami is a real nice way. If you're looking for a 2D focused engine, you'd be hard pushed to find a better one. It's not compromised by having to balance between providing 2D and 3D tools with that focus on 2D. This is where it gets tricky. So scripting and programming with GameMaker uses GML, which is a GameMaker language. So this is their custom in-house scripting engine, which obviously when we talk about other engines, we've talked about C#, C++. These are more common languages you'd be used to seeing and you might have done some work in. So when looking at moving to a new engine, you end up looking at, oh, well, I have to learn a new scripting language, but it is very accessible. It's not too bad. They also have some visual scripting as well. They spend a lot of time curating the engine for 2D games, so it includes a bunch of 2D tools. So we can get sprite editors, level editors, a bunch of other things that normally you would see be an external tool when looking at some engines, and they have them integrated into the engine, which makes it a lot easier to work with artwork and work on projects. They also export to a huge number of platforms. I think if you can pick a platform they export to it, which is actually is a really impressive feat for the engine. Finally, I want to talk about Godot. I think if I gave this talk about 3 years ago, we probably wouldn't be talking about Godot, but it's definitely the up and coming engine. So some examples of games that are made in Godot. So we have Brotato and Dome Keeper. These are actually they're excellent games as well. As I said, Godot's this up and coming engine. It's in its 4th version now. It's growing strength and strength, offers a wide range of ways you can interact with it. So the sort of standard way is GD script. So this is another engine where they have developed an internal scripting engine for the internal scripting language for the engine, along with a visual scripting option. But beyond that, it is also possible to then develop for in C# and C++ with the engine. In fact, it's entirely possible to get the whole entire source code of the engine, fork the engine, and modify and build on the engine as you need. Very strong 2D tools and some really good 3D stuff, especially on the latest version. They made a big push on the 3D side of things, adding in PBR rendering and a bunch of other fun stuff and some additional model support as well. As I mentioned before, it's an up-and-coming engine. Due to, in more recent terms, we're seeing a lot of companies move to this, or at least try it, due to certain decisions made at Unity, which I don't want to get into during this talk. But it happened. We saw a lot of companies very vocally moving to Godot, or at least testing the waters. So it'll be really interesting to see how that shapes up over the years as the games are being built. We find it's a very popular engine at game jams. It's gaining more popularity every year, so it'll be really interesting to see how that goes. And it does have a growing community as well. So actually, I'm just going to ask myself questions now. So does everyone use an off-the-shelf engine? So does every company I know of or have people or have friends that do they all work with an off-the-shelf engine? And the answer is no. Typically, you'll find smaller companies, depending on the game they're making, they may build their own engine or framework. The reason for this is it boils down to the game that they're trying to make. The more unique the mechanic or interaction your game is going to have, the less likely an engine's going to be able to help you. Engines are great at being very, very generic and very abstract. You want to make a first-person shooter, all the tools in the world for you. But if you want to make something really odd, I do a lot of work making custom controllers, and that becomes a barrier to entry when sometimes working with other engines because you're trying to make something that's just it's not common enough to be there. So in those cases, you would find companies making their own custom engines or frameworks to help develop their game a little bit easier. And it's similarly at the top end when you're thinking about AAA, or I think we now have quadruple A. It's too many A's. What you're looking at is companies who will be spending, they'll have dedicated teams to developing their own engine to really push the boundaries of what is possible and what they can do with that engine, or heavily modifying. So when the question comes, well, what about Ninja Kiwi? What do we use? We're not the biggest company in the world. It's not an easy question to answer. So we use two things. So half of our games, we use our proprietary in-house engine. It's built from C++ from the ground up. And we use that for half of our games. The other half, we use a heavily modified version of Unity at the moment. Whenever we start a new project, we have a large discussion around what technology do we need, what engine out there is going to be the best fit. So when I say we heavily modify Unity, we strip out a lot of the underlying technology. So we run a different version of the physics engine. We run our own networking code. We have a bunch of analytics for our games to help track bugs and crashes. We add all that in as well. We still keep some of Unity, so there's a reason to use it. So we still have things like the shader graph, the renderer, and some of the other systems, the AI systems, etc. But there is a bunch that we strip out. So I can't say we definitely use Unity. We just don't use all of it. It's we replace with some of our own bits and pieces as needed. A little bit on engine architecture. The best diagram I could whip up in a couple of days. So what we're looking at is you end up with all these independent systems, and this is why we have the ability to strip out and replace things as we need. So if you look at the range of systems, this isn't all of them, this is just as many as I could fit on the slide, but we're going to have, physics rendering, AI, input management, platform exports, scene graphing, networking, animation, audio, resource management, a lot of that stuff. All that pipes in to fill your engine, along with a collection of tools. In my days as a teacher, we used to get into arguments with students around what is an engine, and what is a framework, and trying where do you draw that line? Where does it stop becoming a framework, and when does it become an engine? And my argument's always been it comes down to tools. If you're getting this really nice, strongly well-built IDE and tool set for help building your games, that's kind of where you cross over from being a framework into an engine. The idea being that we have all of this technology, all this boilerplate stuff and all this technology to help you build your game faster, easier, which is always really helpful. However, I bounce around different engines all the time, and one of the things I notice is their terminology is always is quite different, but they're usually talking about the same thing. So when you're thinking about whether maybe you've done a lot of time in Unity and you're worried about going to Unreal because they're talking about things you don't know, a lot of the time they're just using a different phrase or word to describe the thing they're talking about. So for example, on the slide here, what we've got is the top one is sort of the base object that's in the game, the smallest thing that you can put in a world. So in Unity, that's referred to as an entity. It's empty. It's a point in space, and that's about it. In Unreal, that's referred to as an object, and in Godot, that's referred to as a node. And a lot of people, when they looked at Godot, got worried, like, well, it's talking about nodes and scenes, and I don't know what they are. And if you replace that word, the terminology, it can really help. As we step up from that, Unity has prefab, so this is a more complex object, be an entity with a bunch of components in code attached to it to do something. In Unreal, they don't really have a really good word for it. It's commonly referred to as an actor, because it's more than an object. And then in Godot, that's also referred to as a node. Godot has this very node-driven system, so everything is just the smallest component is a node, and then your node contains lots of nodes until we end up with what we need, or a scene. And then finally, when you refers to scene, what we're talking about is essentially a level, the scene you're going to fill. It's going to have all your components for that part of your game. So in Unity, this is referred to as a scene. Unreal refers to this as a level, which is a little odd because it could be a 2D scene, for example. And then finally, Godot refers to this as a scene as well. One of the reasons I want to bring this up is I think people get really comfortable in one engine and then they get very hesitant about moving to other engines. And a lot of the skills are transferable. A lot of the tools are going to be aiming to do the same thing. They might do it in a slightly different way or look slightly differently or call it something different, but it's not something you should be afraid of looking at other engines or other technology. So, all right, this is where the deep dive comes in. I had to pick something that I wanted to dive into that I think people early, for people studying games programming or looking to move into the industry. There's a lot of this going around. I think a lot of people, it's not as covered as well as we'd like. So this is the point I want to do a big deep dive on. So what we're going to be looking at is the difference between OOD, so object-oriented design or object-oriented programming, versus an ECS, which is an entity component system, versus data-oriented design. So when I first started programming, object-oriented programming was the big thing. If you're a sort of first or second year student, I'm sure you've been doing lots of it. And this is kind of what you're seeing on the screen is what you would expect to see. We have an object, we bundle with that object a bunch of data, a bunch of functions, processes, and possibly some child objects. And this is fine. That object self-contains, encapsulates everything, does everything that we need. If we want something different, we build in a second object, in this case, object 2, which might have some similar data, some different data, some similar functions, some different functions, and more or less child objects. To give you some context, to put this in something more useful, say this is an enemy class that we've been building. It's going to have some health, it's going to have some ammo, but it'll have some processes, whether this is searching for the player, attacking, reloading, etc. And then the child objects will be other parts of that enemy. So physics objects so we can move it around the scene, sprite objects so we can render it, and so on. And this works okay. But what we're seeing in the games industry is a shift. Very common now to use an ECS, and will become, I suspect, a little more common to start using data-oriented designs as we go forward. And the reason behind this is largely performance. Object-oriented approach is great if we're going to have tens of bad guys. But if we want hundreds or thousands of bad guys, this becomes a bit of a challenge for the CPU. So the idea, say we fill a scene with hundreds of enemies. As it goes through that, it has to loop over every enemy, one enemy at a time, and process that enemy. What we end up with is data spread throughout RAM, possibly not in the cache, and it has to be retrieved. This is going to get longer and longer. We might not be processing the data in order. So for example, we might have to loop over all of the objects just to see if an enemy's health is below 0 and they should be getting killed. Then we have to come back to see how their ammo's doing and then possibly process them. We're not always going to do things in the same order. We might have to do it more than once, in which case looping through all of these objects gets very expensive very quickly. One of the ways that we tackle that is by having an ECS or an entity component system, which helps separate out some of these areas so we can optimize it a bit. So what we're looking at now, so this is common, this is something you would see when you're interacting with Unity. Unity uses an ECS as a prime example. So what we're looking at is we break things down into components. So an entity will have references at a component. So what happens is we'll have generic component 1, but this could be a visual component, it could be a physics component, and that will hold the data only relevant to that component. It doesn't need to know about the other components. That's not its problem, it's very focused. So what we end up with is the component which will contain the data that's specific to it, along with any processes, functions, or any systems that we have related to that component. And then those can be attached to entities. Typically, this is done either by some reference or some ID, so we know essentially that each component is in its pool. We create new components as we need them, and they link out to the entities through some ID system. What this leads to is when we want to come and process this, we can process components at a time. So we can go and process all the physics components, for example, and it will only process the ones that have entities attached to them, because it's the only ones that exist as we pull them together. So in the example in the slides, there's only one of those we have to deal with. But when we move to the visual component, it would then run through all of the entities. This gives us a slight advantage. We're only ever going to process one. We're grouping the data together a lot closer, which is going to make it a little bit easier to work with, to be closer in memory, a lot faster to work with, but also we'll only ever process what we need. We're not accidentally looping over additional entities when they don't have, say, for example, a physics component or some other component. Taking this a step further, so what we're looking at is ECS, very common now in engines. And I think it's just something that's definitely worthwhile talking about. I think as people start working with Unity, for example, they get a little bit confused on how all the objects are combined together. Moving forward, looking at a data-orientated design. So I wouldn't say this is in every engine. It's showing up in places. Typically, you'll use this when you need it. I did someone mentioned it in the comments. Unity's DOTS system is a DoD, is a data-orientated design approach. It's not a whole entire new system. It's based heavily on ECS, but it's an optimized version of it. And one of the core benefits of this is allowing for multi-threading processing of your game. So you go back 5-10 years, games, multi-core CPUs weren't all that ubiquitous, or at least not many cores. Typically, we're trying to make the cores go faster. So games struggled because they could only really work on one core. This is being tackled more and more these days, but it was a huge challenge back then, because if someone had a multi-core processor, you'd find one of them was working really hard to render the game and the other ones were just sitting there doing nothing. So by making it a multi-threaded approach, we can harness more of the hardware and run our game faster or have more stuff in it. So what's happening where this differentiates from the ECS, we still have our entities and we still have our functions in our data, but what we're doing is grouping the data together. So what happens is it's aligned in memory. So the idea is when we go to process it, we're not having any cache misses. So what happens is we know the data is sequential, it's going to be in a particular location, and we can run through that data very quickly. It's also, we make it a lot more generic. So the idea is we have a single function that's going to process that data. This is separated out. So in the ECS example, that function and the data are part of the component. Here, what we're doing is kind of separating that out. We have the data by itself, and the thing that's going to process it is now a separate function. And this allows us to run it on either a big pile of data or multiple piles of data asynchronously, which allows us to multi-thread it and give us this big boost in performance. And then the entities are related to that data through a very similar ID system. So the data will have a link out to whichever entity it's supposed to be attached to, in which case, if an entity gets tidied up, we can track that and tidy up the data, so we're not processing or storing any data we don't need anymore because the object's gotten the entity's been destroyed or removed. I want to talk a little bit about visual scripting. A lot of engines, as we talked over the engines at the start, all of them mentioned visual scripting. So what we're looking at is, we'd like to avoid this, right? This is a joke. No one wants spaghetti junction in their visual scripting. What we're kind of hoping for is something a bit nicer and neater. It's not always the case. When it comes to visual scripting, from a programming point of view, I don't do a huge amount of it. Visual scripting is this wonderful tool to help designers and artists spend a little more time in engine helping with the game. It helps them iterate on their artwork or iterate on design, swapping out variables and interacting with your game. From a programming point of view, I'll do a little bit, but I spend most of my time building the nodes. So building customized nodes to unlock or expose processes and data to the code team as well as the design team or anyone working in the engine. So we'd spend a lot of time making sure we're building functionality and adding that into a node graph, whether that's Unity's visual scripting, Unreal's visual scripting, or our own in our own custom engine. There's some advice around these things. A lot of the time it's about keeping them generic and exposing as many variables as possible. So a lot of the time we're seeing we don't want to have things like any sort of magic numbers or whatever. We want sensible default values, and then we want to expose almost as much as we can. Sorry, I lost my track of thought there. The idea is we want them to be generic as possible, or at least be repurposed. So a lot of the time we spend time chatting with the designers because they're like, oh, we wanted to do this. And then a lot of the time that discussion is around, right, do we want it to only do this, or in the future are we going to be adding some other feature? So if this was, to take an example from Balloons, we were adding some functionality for some new weapon. And the question was, oh, we'll just get it to do this. Essentially, we had a cooldown that you could cheat a little with because it wouldn't be global. It would, if you sold the tower and rebuilt it, you could get around the cooldown and get the weapon to fire faster, which we don't want that. And then so the question was, well, it's only what affects this one tower. Can we fix it like this? And so my question is always, is it only ever going to be that one tower? Because we could write a nice, very detailed, focused fix, but that's not going to help us if another tower accidentally has the same problem, or new towers. We're always adding new heroes to the game, always come with new features. So it's possible this would crop up again in the future. So just having to think about what might come back to hurt me in the future, because it'll still be me that has to fix it. So the idea is then thinking about how do we make it more generic and making sure any data we want it to manipulate is some form of input, either that's coming from a file we're loading or from the editor. So it's more configurable, in which case we can reuse it more often, which makes it more useful and don't have to build more as we go forward. Okay, nitty-gritty. So I want to talk about an example project. So this was an example object. So this was from one of our older games. I did have a screenshot so you could see like the Unity file, and it was too big. It didn't fit on the slide, so I had to break it down. So this is essentially most of the variables. It's not all of them. As many as I could fit on a slide that we expose for one of our gun objects in one of our older games, SAS4. And as you can see, there's a huge number here. There's a couple more that I couldn't fit on the slide, but there's some really interesting ones. So obviously there's the standard ones you would think. We're making a gun, we care about its range, its fire rate, its reload time, magazine size, and fun stuff like that. But we also track its handedness. Is it a one-handed gun, two-handed gun? Is it shoulder-mounted, etc.? A bunch of other things. So we'll control projectile data, so we could swap out all the different projectiles, so we can make it shoot different things. Similar for emissions and VFX. But then we go even further. So things like the icon that you see in game, that is controllable through this object. The animations can all be swapped out. We have alternative versions of it for menus. And so the idea is that almost every gun in the game can be made with this single object, because we've made it as generic as possible with a huge amount of variables we can control, so we can swap out. Some of them might always be the same. Typically, they're always going to be changed, different VFX, different animations, and so on. But it gives us this very generic object, which is really easy for people to drop in, swap out, and try new things. We could do all this in code, but then having gets challenging for other parts of the team to come in and say maybe they want to try out a new VFX, or double check object sizes are the same or something, so nobody's guns as big as they are, things like that. By exposing these variables and making them easier to interact with, we just make it a lot more, it makes it faster, a lot easier for other members of the team to interact with the game at that level. It's one of the true saviors of using a games engine, is being able to get everyone in. For our own custom engine, we had to develop a bunch of custom tools, and they work, but they could be a little bit clunky in places, which is why we don't show them to the world. So as a lecturer, I used to get asked these two questions all the time. So what is the best engine and what is the best language? Sadly, there's no best engine, right? There's an engine that's really good for what you want to make, but there's no best engine. So I can't say you should all go learn Unreal. No, I think you should go learn as many engines as possible, because that's always going to be better. And then similar with languages. What's the best language? Well, what are you trying to make? I would argue the games industry, the sort of de facto language is still C++, which may change at some point in the future. I look at Rust with intrigue at the moment. I don't think it's quite ready, but it's getting there. It's something I think definitely worthwhile watching over the next couple of years to see whether we make that move away from C++. Obviously, there are a huge number of other languages that are very common, things like C#, especially with Unity and other languages using that as a form of scripting. But all these tools are still built with C++. For the obvious reason, it's closer to the hardware. We can get it more optimized. We can make things run faster. And the games industry is known for building all of these tools so we can make games faster, and then we just make bigger games with them, so games still take just as long to make. So when it comes to thinking about starting a new project, you come to think about what engine should I be using, what language should I be using. Essentially, ask yourself these three questions in this order. The order is particularly important. I find people seem to do this back to front. So what you're thinking about is, what type of game are you trying to make? Is it first person? Is it third person? Is it going on mobile? Is it going to have some wacky controller? Is it going to be, high-end, hyper-realistic graphics? Is it going to have lots of physics? All of those things. And then find the engine which has features that strongly align with your game. If you make it a 2D game, then there's a couple of engines, as we mentioned, Game Maker, that's dedicated to 2D games. That might be a really good fit, or at least a very good place to start. Unity and Godot have good 2D systems as well, so they're in contention, but you might not be looking for something that's got super high-end, ultra-realistic 3D visuals. It's just not going to help you make your game. Narrow down your engine choices. Make sure, a little bit roll the dice just to make sure it's going to work. But the more times you build something with an engine, the more comfortable you'll be. It's a good fit for your game. Once you've narrowed down your engine, then you have a pick a language. So some of them, this might be a choice. So for example, in Unity, you could choose just to go with C# scripting, which would be perfectly fine. But also, if you wanted this, if there's areas you were building that might be reusable or need to be performant, you can build them as in C++ as a library, which can then be loaded into Unity. So you can get the sort of benefit of both, and you wouldn't pick one to do everything. You probably use a mix of both of them, depending on, again, it largely comes down to what are you building. With one of the games we're building, we need things like optimized networking, and we need to handle the physics in a slightly different way. So we use our own versions of those, but it's easy enough to swap those out and import our own libraries into Unity or other engines. If we're using Godot, similarly, they have pathways for writing in C# or C++. And then from there, you can pick the language, which hopefully helps. Hopefully I don't have to answer those questions again for another wee while. Almost year on year, I get asked, "Well, Paul, what's the best engine?" finally end up with some advice. This should give us some plenty time for some questions at the end. So some coding advice for juniors, so people graduating or thinking about or looking at getting into the industry for the first job. Read the style guide. Your company, when you first join, will have a coding style guide. This will help you, should help you quite a lot. Before you get the job, have a look at some that exist already. So you can have a look at C++ standard library. They have a style guide. Google have a style guide for all their code. What is going to help you as your first time in the job is helping to make sure your code matches and aligns with the code base you're already working on. This is going to make it easier in the long run to find things and to navigate the code. A lot of this comes down to really simple rules around: are you naming your variables sensibly? Are you making the correct number of methods and objects and services? As well as some people, they will differentiate between what the function does. So if it's a function that can be overridden or inherited, it's the way you write the function name would be different to something that's just processing data, for example. So you can tell at a glance how quickly it's going to be, at a glance what that function is roughly going to be doing and whether or not we need to move it. Build for customization. So this goes back to those the talk around the visual scripting, as well as the next bit of future-proof your work. It may sounds easy just to say it like that, but thinking about when you've got a task, you got to build something, sitting down with that designer ahead of time, going, right, you've asked it for it to do this. Could we make it more generic? What might happen in the future, and try and get a feel for: is it just this one-off little small feature, or is this something that might come up in the future? So we can try and prepare for that and make your life easier in the future. It's a little bit legwork to start with, but future you will definitely appreciate it. The other thing is learn programming patterns. There's an excellent book on this called Game Programming Patterns. You see a lot of these in Engine, and it comes in handy to understand why they're there and why they work they do. So whether this is something like a singleton pattern or an observer patterns everywhere. It'll come in really handy when you interact with these things, either in the company's custom engine or an off-the-shelf engine, to understand how these things work and why they've been implemented the way they have. The other thing is be willing to learn. There's always going to be other technologies and languages that you will have to pick up that you might not have had experience with. So that means you might end up having to configure things like build machines or work with them, JSON or XML or something else for storing data, which will obviously be encrypted, along with other scripting languages for automation. So this could be looking at things like, you spend a lot of time in C++, but you might end up writing lots of C# or Python for automation or scripting. I did write down a bunch of other languages. There's too many in my day job. Oh yeah, Bash and Batch. Spend a lot of time in the command line. Get familiar with that. Probably not as for a junior, but as you progress from junior to programmer and as you progress in the industry, you'll find you'll be doing more and more of these things. So you have the time. You don't need to know it all before you go in the front door. Just be aware that it's coming, and be ready to learn. It'll go well. Ask all the questions. We take on graduates fairly regularly, and the best piece of advice I can give them is just pester me all the time. I would rather they ask me a question rather than sitting there worrying. I know imposter syndrome is all too much of a thing, and so I check in on them as much as I can. But having them ask all those questions doesn't matter if they think it's a silly question or if it's an important question, especially because we work with a proprietary engine. There's no way they could learn what it was beforehand, so they are coming in and getting kind of thrown in at the deep end a little bit. So it's me, myself or a colleague, we're usually around to answer all those questions, especially in the early couple of months. And so for anyone going into a company, no one's going to be upset you ask a question. They probably welcome it. They're not as scary as they look. A little more general advice. For anyone sort of going through this process leading up to the industry. Portfolio. A portfolio is priceless. Show off anything that you're making. Doesn't matter if it's finished. Doesn't matter if it's broken. What we want to do is from someone who hires people, we're interested in what makes you you. And if that's just university coursework, we want to see a little more. So do game jams, have weekend projects, have something to show off, do something that shows you that you can demonstrate teamwork. Building games is hugely collaborative effort. I think secretly everyone wants to make games by themselves, and nobody can. So, I mean, I'm a really good programmer. I mean, obviously I'm a little biased, but my artwork is terrible, so I'm not making a game by myself. So what we need is someone who can work in that team. Dive into source control. Day one of your job, you will be asked to use the source control of choice to get the latest build of the game. So make sure you're not caught out at the first hurdle. Typically, games companies will work with either Git or Perforce. Learn one. Most of it is a transferable skill. Have a look into other industry software. So companies will use things like Jira, TeamCity, and a bunch of lists of Jira for task tracking and bug tracking, along with some Crashlytics software, etc. The idea is just to try and familiarize yourself as much as you can with this software. And for a lot of this stuff, start small. Feature creep is an annoying bad habit. Yes, it's one of mine. So doing things like game jams or small projects, always try and start small. Having more of them, you'll learn more about the software you're working with, whether that's a games engine or trying to build your own. And you just learn more rather than doing one sort of bigger project. But then, start small. Each project can get a little bit bigger each time. Attend industry events if you can. Networking is a huge part. It's one of the reasons I'm here talking today. I bumped into Game guys at a games industry talk event, and we're talking about some of the outreach that Ninja Kiwi do, and how we might engage with them. And so I drew the short straw for giving the talk. A lot of the time you want to speak to the company directly. They may have positions that aren't being advertised. They might have opportunities for internships over the summer, things like that. Definitely worthwhile just reaching out to the company politely to get some feedback on that. It's not something they will necessarily always advertise. We work with a bunch of local universities, colleges, and schools to have people in for work experience. And so part of that is, while it is done through the institution, it's done by those students highlighting this is something they would be interested in. And then finally, explore new frameworks. There's always new stuff coming out. Trying to keep on top of it all is near impossible. Do as much as you can. So whether that's tinkering with a different engine, playing around with some new framework, looking at some new technique. I tend to try and double jeopardy this at game jams. So I'll go at a game jam and then use a completely new engine I've never used before, which just makes that game jam a little more challenging, a bit more fun. But yeah, so things like that to have a think about. And then finally, questions. I'm sure Jonas is hiding around somewhere. We'll do our best to go through some questions.
I am indeed hiding around. I was actually just reading a question in the chat, and then you sprung the keyword upon me. Well, yeah, I'm back. I'll put that to the side just so that everyone knows that we're in the question zone. Yeah, thank you so much for all that, Paul. Some really delightful stuff. Definitely some stuff that went way over my head, but I'm sure anyone who understands what an object out of the context of, I don't know, the things around my house is, I'm sure had a huge amount to learn from that. So thank you so much. I'm going to start scrolling up just slowly through our chat now, because some questions have got asked throughout, but you also did pick up on quick questions, I think, and you sort of bundled them in. Yeah, okay, cool. I know which question I'm gonna start from. Right, let's go for this now, and we can bring up the question directly on the screen. So Sneaky09 asked a bit of a question not too long into the chat there, which is when do you keep going with messy code versus when do you take the time to refactor? I struggle with the balance between getting things done and finished versus having it future proof to add more content. So I know the word technical debt comes to mind here.
Oh, yes, every day. There's far too much where we're just like, we need to deal with that in the next update. So no, panic times. This is tricky. I think once it gets working, once you have something working, so yes, a lot of the time when we're developing a new feature or a new system or a new service, it does start off very messy. Once you get to a version that is working, I think that is the key time to think about when you can do a little bit of a refactor. Typically, one of the challenges with coding is it's always better the second time, right? But we don't have time to do it twice. So yes, I think build it. If it is messy, you'll have learned a lot about how you want that service or that system to work by the time you've got to the end of the very messy version. And then from there, that's kind of if you have the time, that's where you want to target the refactor. One, it's going to be fresh in your mind, but two, you'll have some ideas on how you could better structure it and what is expected. Some of the times, as you're going, you're solving this problem on the fly, and until you have the solution, you're not going to know necessarily the best way to factor it. And this gets tricky. You got to pick your battles. Not everything is going to be major. What's the impact it's going to have on the game as a whole or the system as a whole? So a lot of the time we struggle. Obviously, we make games where monkeys throw darts at balloons. There's a large number of projectiles. We have a large number of different aiming methods. So we spend a lot of time optimizing where something that's going to happen a lot. Depending on your engine, there are debug and performance profiling tools that can help identify this. So sometimes it's a case of, is the refactor just because the code's messy, or is it going to have a bigger impact on the game? So if there's a performance implication, then that's where you should be focusing that effort. Sometimes code's just got to be messy. Don't tell
Brilliant.
my boss.
No, I think that's a really great answer. Thank you, Sneaky09, for the question. Next up, so I noticed a bit of chatter picked up on coding style guides, and then Techno Jester came with the question: do you have any advice on picking a styling guide? Would you recommend looking for a style guide online? And if so, are there any good resources for that?
If it's for a personal project, then the style guide becomes down to sort of like personal taste. If it's for a company, they should have one, so follow that. As I suggested in the talk, the Google one's really good. It's a lot more detailed than it needs to be. I think they get hung up on being very specific about things. But the key things to take away are like, how do they name variables? How do they name functions? What about static variables? And things like that. To help you, just helps make the code a lot more readable. Don't be worried about having variable names that seem too long. Avoid unfamiliar acronyms, things like that. So the Google one's really good. I mean, you could take a look at Hungarian notation. I don't recommend it. We have a little bit of it just because highlighting C++ comes in handy. You'd be like, this is definitely a pointer, and you know it's a pointer before you have to go deal with it, which comes in handy. And then the one for the standard C++ libraries, they have that published somewhere, not off the top of my head. And it helps you whenever you're working with, and they'll be similar for C# as well, I'm sure. But it helps you understand why they take a slightly different approach, with it all being snake case with some things, but not everything. And they have some interesting reasons around that. And I think if it's your own project, have a look at some examples, build your own one, see which rules they're applying and why they make sense.
Nice, thank you very much. Just balance our cameras out again. The next question, where are we? We've got sort of 10 minutes to play with everyone. So by the way, so if you've got a question, throw it in chat. I can see that there's quite a scroll down list there. We'll do our best to get through as many as we can. Paul, do you have questions from Hannah Guichard? Sorry if I say that wrong. Hannah asks, do you have any advice for building the foundational programming skills if you're coming from the art side of the industry?
Yeah, I spend a lot of time helping some of my colleagues who are interested in picking up a bit more programming as part of their job. So one of the big things is, I think, definitely use an engine. It's going to help you build something you're going to see a lot of the impact very quickly. And I had an answer in my head, it's just ran off. Give me a second. Have a small project. So one of the challenges I had as a teacher, especially over the pandemic time, is people learning from YouTube. I'm not having a go at YouTube, but what I mean is they follow a very strict example, and they build that, and that's fine. As long as everything goes well, you've built a thing. Find a nice video on how to build a game in Unity, no problem. But what you want to do, the crucial bit from there, is then extending it or modifying in some way. Because a lot of the time, if it's just follow along, copy and paste the code, click that button over there, you're not breaking it down, you're not seeing the process, so you're not going to learn as much. It'd be fine if we just wanted the same thing again. You can rinse and repeat and copy and paste, but what we're interested in is learning that why things work the way they do. So I think starting with a small project and having that tutorial just to get something working, but then extend it. So when we do work with schools, for example, we have them build a sort of retro game, Breakout, Space Invaders, something like that. And for the younger people we have them work through a tutorial that takes them through step by step, adding, start with player movement, start with adding enemies, adding collision detection, adding bullets, and so on. But then the crucial bit after that is, once you've got the sort of base game working, is what do you want to add to it? And it could be anything they want. So they could go heavily down the sort of VFX and visual side. They could make some really interesting new mechanics. But the idea is they build on what they've been learning, piecing together the project, and you will learn a huge amount more doing that extra step. It's always going to be that extra step that's going to push you over the edge.
Nice, thank you so much. Next question is Danny Watson on the viewing from LinkedIn. Hello, LinkedIn viewers. Asks, is it okay for juniors to not have a degree but plenty of personal projects and learning?
Oh, that's a good question. It's a difficult one to answer. I think while it is now definitely the most common route into the industry, especially in the specialisms of things like programming, art, or design, you're coming from that having a degree, coming through university, having a degree to demonstrate you have that knowledge. But yes, it's possible. I think it might be tougher, so definitely a lot more work. But having strong projects and demonstrating the learning, I mean, if you go back 20 years, people who started the industry, they were learning it all themselves anyway. So, most companies got started by people who didn't go to study this at university because they couldn't. I think it's a lot more common now to have that degree route, but it's not impossible to do it without it. I think you need, yes, very strong portfolio and to demonstrate your learning, and you'd be fine.
There's actually a really good related question a bit further down, so I'm going to skip a few questions just because I think it's really related. Artonkus just says, any advice specifically if you're trying to get into making games without any education relating to the industry?
Yeah. I was going to name drop something that's terrible. So the first thing I do is go watch my FutureLearn course on. It's a nice taster test on introduction to programming in games and making games. That's terrible. I shouldn't have done that. It's a short 2-week course. It's free. It was supposed to be longer, but it was a short intro to understand some of the core systems in making a game. But to actually answer your question, picking up, similar to actually the question above, picking up an engine and working your way through a project. Have a very small project in mind, and I mean smart. Start tiny, and then just build your way up. Having lots of small games, you will learn a huge amount more than trying to have some one big behemoth project. It's where my aversion to feature creep comes in, and I'm guilty of it too. I've got weekend projects I'll probably never finish at this point because I keep adding stuff to them. But having that, pick an engine. You want me to pick one for your game maker. So if you're making a 2D game, it's definitely worthwhile. It's very new person friendly. They have free art on the website, a bunch of tutorials you can work through by the people who made the engine, along with to help you get started. And just make games. Once you've made a couple, attend a game jam. I love game jams. Everyone gets scared of them because it's 40 hours to make a thing, but you don't have to make a thing. You just have to try and make a thing. And sometimes it goes well, sometimes it doesn't. But it's a great way to meet other people, to test block out some time and get a project knocked out. So
Yeah, over at Into Games, we are massive game jam champions. We're constantly pushing people towards them because nothing fills out a portfolio like you making a game every weekend, or you having like 7 small projects that you can kind of see the impact on in such a small amount of time. And I'd say if you sort of spent 3 years, I don't know, in like a learning environment, or you spent 3 years making a game jam every single weekend, like they it's unreasonable to ask. It's quite a lot of work to do a game jam every weekend, but if you did it, the output you'd have would be incredible. Like the amount you would learn and the amount you'd actually kind of be able to show for it would be absolutely astronomical. So yeah, do dip your toes into game jams, people. By the way, I've put your FutureLearn course on the screen for everyone. Go look that up. Put that in your back pocket. I can repost it in the Intergames Discord later if you want it. I'll take it off the screen now just so we can get back to the comments. Thank you so much for the answer. Let me just go see what people are asking at the moment. I've just scrolled down and zoomed in on one that I think is a great question, which is so Emmy asks, what's the most important thing that you could test a candidate for in a coding interview or task. So I suppose really the question is like, what are you looking for in juniors in coding and programming?
Um, Probably two things. The first one has nothing to do with coding. One of the things that we tend to do is we do interviews first before we do coding tests, and largely from that is we want to see how well you fit with the team. Are you a nice person? If you're not passing that test, we don't want to work with you. But it's a really effective system. So will you fit in the team? Are you a nice person? And then after that, it's how you solve problems. We don't expect perfect code every time. Depending on what the code test is, what we're interested in is, can you solve the problem? Typically, we don't trick anybody, but if someone says, I don't know this, but this is how I'd go find out and solve that problem, there's a book on it somewhere on my shelf I should probably read, things like that. But I think it's definitely down to how you're solving the problem, and are you a good fit for the team.
uh, Definitely like what's the word I'm looking for? Like studio culture is a really big part of the conversation. Like when it comes to job hiring and things like that, and the number of different recruiters and hiring managers I've seen who have just said like, yeah, a lot of the time it comes down to like, would that person get on with us and would we get on with that person? Because in the end, they are probably going to have to learn a lot of new skills when they enter the office, and there's no accounting
Yeah.
for that. Like it's going to have to happen.
No, as
Um,
long as as long as we've got that sort of like base understanding, we're quite happy. The expectation is we will have to spend time mentoring and adding to your knowledge base. But the office we have, so Ninja Kiwi has two offices. We have one here in Dundee and one in Auckland in New Zealand. It's hard to have a conversation with those people. But the office is small. We got 40 people, so if we were a massive company, you might be able to hide off in a team somewhere, but you're just always going to be there around there, and you kind of need to be able to work with your colleagues. So it's super important. A while back, I know there was discussions around what they referred to as like 10x engineers, um, about these people who don't attend meetings but they're really great coders. I'm like, yeah, but they'd be really great at it, but they're just not a good fit for the team. There's a trade-off to be made there.
mm.
Some savant coder is probably not going to be worth it in the long run, I don't think. Or at least that's my excuse.
Yeah, I don't know. Like, I love food analogies, right? It's like most talented chef in the world, but has a penchant for punching customers in the face every day. Like, do you really want to run a restaurant with that guy? Like, maybe not. Food will be
Brilliant
great though.
analogy.
Food will be
Yeah.
great. Like, yeah. So pick and choose your battles there. I think we're pretty much just hitting the hour now. So I'm gonna bring the sort of the conversation to a close there. First off, thank you so much, Paul. Thank you for joining us. Thank you for doing this on such short notice. You mentioned earlier we just absolutely wrangled you in at sort of T minus zero there. But I think you've absolutely rocked the mic. I think you've absolutely you've come out with some really brilliant knowledge, and clearly everyone chatting has learned a lot from this talk. So thank you
Yeah.
so
Thank you very much.
much. And then thank you to the audience as well. Thank you to the audience who have asked your questions, who have been chatting, who have been engaging, who have come here, and made this event sort of very much worth it. Like we do it for you. We do it so you guys can learn, so that you guys can kind of take away a lot of these knowledges and skills. Hopefully, you can pass this advice on to somebody else, like who's sort of looking for these opportunities. By all means, share the YouTube link around. Let people know that these events do happen, and that that if you think it's valuable, feel free to tag that on the end. I don't want to put words in your mouth. We're actually back with another discipline deep dive tomorrow in community management. That one's going to be led by Toby Palm, head of community at Square Enix. It's going to be hosted not by me, but by Jupiter Hadley, who is the head of community at Toya. I'm going to say the words in the wrong order, but it's like Toya Play Studios. They do Roblox. So if you're interested to hear about community and what it's like to basically sort of talk to potentially thousands of millions of people on behalf of a game or a studio, and to kind of represent a product to a wider audience, I think that'll be an amazing thing to come along and talk to. Especially because community management is where a lot of people do find their early beginnings in the games industry, like me. Thanks again for joining us, everyone. And if you're not already part of the Intergames Discord, there's a link somewhere in the YouTube comments below, or give it a Google. Jump in, say hi, have some conversations. If there's any questions you didn't get answered today, pop them in the Intergames Discord. We've got a lovely little chat called Ask the Community. There's over 8,000 people in that community, so roll the dice and someone will absolutely know the answer to your question. Right, I'm going to end the stream there. Thanks again, everyone. Bye bye for now.